primary work that I'm involved in is establishing something called the Deter project. Deter is a cybersecurity testbed, facility, and research program. So all these different computers can be connected together in very arbitrary ways that let you emulate the real internet. We're really looking at what are the behaviors in the malware space and how do we start preventing those kinds of bad behaviors. We have deep technical staff with lots of longevity, and that's what you need to actually build something and get it out there. And so we bring in the best of breed in academic intellectual research and bring in the engineering staff and the software development background to be able to build real things. And then lay onto that, we have graduate students, and so we're always getting new blood and new ideas involved.
So the work that we're doing here at ISI is creating the basic plumbing or connections that allow data to be moved securely and reliably and with great efficiency from one place to another, and organizing and managing that very complicated information. So working in the health space has been very exciting and rewarding. It's allowed us to apply our research so we can have real societal impact. For example, we've built systems that allow X-rays or MRI images to be shared across networks between physicians, and also to support research into diseases like schizophrenia and bipolar disorder. And so this has been a fantastic place because we've been able to build and evaluate and have an impact in ways that we couldn't have had anyplace else other than at ISI.
Some of the strengths of artificial intelligence here at ISI include the work that's going on in natural language processing, machine translation, knowledge acquisition, knowledge representation, and machine learning. We've looked at linking text documents to locations, so we can take things like news articles or tweets or blogs and automatically linking those to the actual locations that are discussed in those articles. One of the areas where we're the very first people to actually do something in this space is on our extraction of data from online sources. We developed an approach for automatically predicting whether or not a given airline fare was likely to go up or down.
Project that I'm very excited about is collaborating with biologists on drug discovery. We're replicating their methods so that they can apply them very efficiently to new diseases. We're working with the World Wide Web Consortium to develop standards for the web so that you can see for any web document what its origins are, so you can determine whether you trust it. We're trying to collect data and knowledge from 1,000 scientists that study lakes all across the United States and integrate all of this knowledge. So the challenge is to get people and computers to work together to solve big science questions that could never be possible before.
Moses was the pioneer in demonstrating the multi-project wafer system of sharing the prototyping needs of many different customers onto a regularly scheduled service. There is no self-supporting organization that does this service anyplace else in the world. The multi-project wafer allows each individual organization to pay a small fraction of a very large cost of manufacturing their custom integrated circuit in a shared fashion. So in the last 30 years, we've continued to stay at the state of the art of manufacturing, and today we are working on carbon nanotubes, 3D integration, and photonics.
We have two main projects at the CERC. One is a student-run Leapfrog lunar lander, and another one is the small satellite, the nanosatellite program. In August, we'll be launching the Aeneas CubeSat. It's the first CubeSat with surface tracking and the first half-meter deployable dish. These smaller launches are leading to bigger missions of national interest. It's a unique situation because we're able to take industry people and then connect them with students. We're educating that next generation of engineers to be able to design and build and fly satellite systems. So we're very proud to be able to be doing that here in the U.S., in our backyard.
Well, the system we're working on right now is for recognizing and interpreting metaphors in text. Intelligence agencies can use our research to interpret metaphors and thereby gain access to kind of the underlying cultural principles of other peoples. One thing about ISI is that it has possibly the best natural language group in the world.
I've been in the high-performance computing business now for a quarter of a century, ranging from things like designing nuclear weapons to understanding the origins of the universe, designing cures for cancer. So we're trying to lead a revolution in the algorithms that people use to program computers, the software they use, and ultimately the problems they can solve. So together with Lockheed Martin Corporation, we have the world's first commercial quantum information processor. So the next generation D-Wave machine ought to be the most powerful optimization machine in the world, and we'll apply it to a variety of things, including software verification and natural language processing. So ISI helped give birth to the internet, and now with the D-Wave, we're going to give birth to a new generation of quantum computing.
Because ISI is part of the University of Southern California, it provides a number of features that I think make ISI unique. In particular, the ability to work with graduate students, teach classes, and collaborate with people in other departments and across various disciplines.
Being part of ISI means I have a staff of people who are dedicated to doing the work and to seeing the technology transfer happen. And you don't find that in a pure academic setting, nor do you find it in a commercial setting. We really blend the two.
We attract talented and skillful students who are interested in not just studying computer science for computer science sake, but who want to make a difference on the world.
ISI gives us an opportunity to build real things and field real things.
It's exciting to be a pioneer. It's like being in the 1950s all over again.
What's exciting for me is that I think computing and science advances are going hand in hand, and I'm right in the middle of it.
The opportunity to work with people who created the internet was a fantastic opportunity. Building on that, we were able to create new technologies that have, in some sense, revolutionized the way we think about networks and science and doing distributed collaboration. I can't imagine any other place where I could have been able to do this work other than ISI.